Let's get into some examples on composite functions. So keep in mind, we had discussed that we're actually going to be substituting the functions into each other. All right, so here's example number 1. We have two functions and we're going to substitute them into each other depending on what the question asks us to do. Okay, so A is asking us to find f of g of x, which means that you're looking for fog. Okay, so take the g of x and put it into the f at x. And how do you do that? Well, first of all, it kind of looks like this. You have your f at x, but within that you have your g at x. So within your f at x, you have your g at x. Okay, so that means that wherever I see an x value in f at x, I'm going to put all of this because this is now my domain. Okay, so this is the domain for my f at x now. So take a look, I got the -4 from right here, f at x, and then instead of the x, I'm going to write the g at x. So that's basically what you're doing in order to substitute. Wherever you see an x value in your, outer function, you're going to substitute your inner function into that x. All right, and now you're just going to simplify. So take off the brackets and put any numbers together that you can. So that's just 1 minus 4 gives you the -3, and the 3x stayed the same. So this is the function for fog. Now I'm going to get you to look for GOF. Okay, so you're taking f at x and putting it into g at x. So g at x is on the outside, and I've color-coded this so that you can kind of follow. All right, and then your f at x is going to go inside. So your g at x is going to have your f at x within it. This is now the domain for your g at x function. So that means wherever you see an x value, you're going to substitute all of this instead in a bracket. Okay, so there's the 3x plus 1, but instead of the x part, I'm going to write the green part. Okay, so we've now substituted f at x into your g at x function. Expand and then simplify. So 3x, -12, and then the plus 1 goes right there, and then you're just putting those guys together and you get this. All right, you see, it's like a little bit tricky with the mind, but once you get the hang of it, it's actually not too hard. Okay, there is one other question at the bottom. Do you notice anything that's different between fog and GOF? Like, a lot of people think, okay, so we're just substituting them into each other. Shouldn't we have the same answer? And you really need to notice that they're actually not the same. Okay, you don't get the same answer because this is 3x minus 3. This is 3x minus 11. So they're not commutative, which means fog is not the same as if you just rearrange it to GOF. Okay, so let's find C and G, which is FOF and GOG. Anyways, all right, so you're just substituting f at x into itself, f at x. It's going to look like this. Okay, so we're substituting green into green. So within your f at x, you're going to have x minus 4 as your domain. Okay, that means within your x minus 4, you're going to substitute your x minus 4 into your x value. Okay, so there's the -4 part, and instead of your x, you're going to write the other the other f at x. Okay, so this is the f at x within the f at x. I know this is a little bit confusing. It takes a little bit of practice. Take off the brackets and just simplify. All right, so FOF equals to x minus 8. Let's try GOG. Okay, so you're going to take g at x and put it within g at x. So you're taking the 3x plus 1 and you're putting it into your x for the 3x plus 1. Okay, so it looks like this. Within g at x, you have g at x. So within g at x, you have whatever g at x is. Now take this and put it into your g at x wherever there was an x before. So here is g at x, and then you're taking the domain and putting it into where your x was. All right, so this is g at x within g at x. Now expand and simplify. All right, so 3 times 3 is 9, 3 times 1 is 3, and then you got your 1, and put those guys together, and you get 9x plus 4. So here's a question at the bottom. Is FOF actually equal to f at x but squared? Because that's a common I mean, a common thing that a lot of people think. All right, so let's check it out. I mean, you already have the answer for FOF right there. So let's try to figure out what f at x squared is. So here is f at x minus 4, which was right up here. And then if we square it, we actually get this, which doesn't even really look like that guy. So not really. I mean, FOF is not the same as f at x squared. And that actually makes sense because if you think about it, f at x squared means f at x times itself. So it's actually doing an operation where it's multiplying itself. But FOF is not a multiplication of itself. It is an f at x within another f at x. And that is not a multiplication. It's a substitution. All right, so there is a difference, and that's just a really common mistake that people make on a test. All right, let's now use those inverses that we actually figured out from the warm-up. So you know what, why don't I put that down? We figured out the inverse for f at x before, and we had also figured out the inverse of g of x. Okay, so now we're going to use these functions, your blue and purple, in order to find these ones. And I don't know what these ones are called. It's not FOF and GOG or whatever. It is inverse of f of g at x and g of inverse of g of x. Okay, so same thing. You have your f inverse, and you're going to put g at x in there. Okay, so g at x is the red one. All right. So within your f inverse, you're going to put 3x plus 1. That means this 3x plus 1 is going to be substituted anywhere there's an x within the blue function. Okay, so there's the blue function, and then we're going to substitute your g into it, and then we expand and we simplify. All right, this one is your g inverse input into your g. Okay, so there's your g, it's in red, but you're going to input the purple. So the purple looks like this, right? We figured this one out in the warm-up, and then now we're going to substitute this into wherever you see an x in the red function. Okay, so there's a red function, and then we're inputting your domain, which is the g inverse. So you're going to simplify this by multiplying into the bracket, but these 3's cancel out, so you're left with the numerator, x minus 1, and then your plus 1 at the back. Now that negative 1 and the plus 1 are going to cancel out, and you get x. So what did you actually notice about when you put the inverse of something into the original function? Well, all the numbers seem to cancel out, and you're only left with an x at the end. And that's actually kind of like a rule. So let's go over the rules that we've actually learned. Okay, so first of all, FOG is not the same as GOF. They're not commutative. You can't just like, if you take G and put it within F, it's not the same as putting F within G. Okay, so you're going to get different answers. The other thing that we actually learned was that there is an exception, and that is if you take the inverse of something and then you put it into itself, or you take itself and put it into the inverse, you actually always get x, no matter what. Okay, so we just saw that in the previous slide. So here's the last examples, and that's where, I mean, why don't we start with some more difficult questions, okay, where we have some roots. So we have two equations right here, and we're going to find FOG. And then we're going to find FOG when your x value is 9. Okay, so first of all, FOG. Take your f, put your g within it. Okay, so since g is this root function, we're going to take this root function and put it into your f at x wherever there's an x. Okay, so here is your f at x function, 2x plus 3, so 2, and instead of x, you're now going to write your g at x plus 3. And if you can, I mean, simplify it, explain and simplify, but I mean, this is as far as I want to go because I can't really square root anything underneath the square root sign. So that's good enough. If I want to go further and I say, okay, within this function of FOG, I want to know if I take an x value of 9 and put it into this function, what is my y value going to look like? So you just substitute 9. Okay, 9 squared is 81 minus 5. Okay, so you get something like this, and that's going to give you 76. And I mean, you could square root it, or you can try to simplify it a little bit and break it down. So I broke it down to 2 root 19 using grade 11, I guess, skills. And then you get 2 times 2, which is 4 root 19 plus 3. So if you wanted an exact answer, you just leave it like that, or you can always convert it to a decimal answer, which is rounded. And then I just put the approximation dot. All right. So, I mean, thanks for staying with me for all of advanced functions. I didn't do 8.4 because my class just ran out of time and this was my first time teaching. In fact, I feel like I have a better understanding of this course because I made all these videos for you guys. So thank you for allowing me to do that. This is almost like teaching it twice. So I hope that they've been really helpful and I wish you all the best on your course. Okay, so if you have any questions, definitely just feel free to just message me below. Okay, and good luck.